Now we talked about cloud. What is cloud computing is whatever operations we do on cloud, okay? All needs a compute infrastructure, all needs a compute power. That's what a cloud computing is, okay? Now, based on the various services that a cloud provider provides us, there are different types of cloud computing. First is IaaA. Yes, the full form is Infrastructure as Service. Okay, we called it as PaaS, PaaS, Platform as Service, SaaS, Software as Service. Okay, these are the types of cloud computing or service models. There are different terminologies, but in simple terms, you can call it as the service models or types of cloud computing. Okay. Now, what is infrastructure? We talked about the infrastructure here, right? It is nothing but the storage or compute machines like hard disk or RAM in simple terms. Okay. That infrastructure, when you opt for from a cloud provider, okay, you're opting for an infrastructure as a service. Okay. To give you an example, virtual machines are examples of infrastructure as a service. Okay. If you don't know what a virtual machine is, don't worry, we can talk about it when we start on Azure. Okay. Now, platform as a service. Okay.
Power BI service can be platform as a service.
Yes, correct. So when you get the offering of hardware plus a software in a single service over the internet, okay, that is basically the platform as a service. Okay. So just someone mentioned the Power BI service, which was a good example. We have separate app service also in Azure. That is also an example of a platform as a service. Okay. Now, software as a service. As a name
Snowflake.
states, Snowflake is a software as a service. Yeah, you can tell it, but it also provides you infrastructure also in the backend. Okay, so in software as a service, the very basic and simple example you can remember and relate to is Office 365. Whatever bundle of software comes with Office 365, your Outlook, Teams, OneNotes, and whatnot, all these are software as a service. Okay. Any question in this?
No, sir.
No, sir.
No, sir.
Okay. Let me see. Before we jump on to Azure, while talking about data, I mentioned your data is everywhere, and that's why every company needs an in data engineer or data analyst or ETL engineer. Okay. So the future for the data engineer is there in every organization, every company. You might wonder, like we all know about the private companies. Okay, assuming that we all know. I don't want to take any names, but including all the big four companies or big six, whatever, from India, outside India, to all the names that you know about service-based companies or small-scale companies or startups, everyone needs this. Okay, they need data engineer, they need data analytics, and all that. Even the government is not. Let's not put the governments. Even the banking institutions, like you know, the State Bank of India, STFC. These are the banking institutions, financial institutions. Even though they hire the vendors like other service-based companies to do their job when it comes to technology, not the financial banking stuff, inside them also they have their own data engineers. Okay, there are many people who have shifted from private companies working for data analysts or within a data role, some sort of data role, move to that institutions, and vice versa. Okay, So there was a scope for data engineers, there is a scope for data engineer analyst or data related jobs, and there will be always in the future. Okay. Now, the scope, the definition, the role, the technological skill set will always evolve, will always vary, and we need to keep up with that. 10 years back, there was no cloud, it was on premises. After 10 years, there is a cloud. Today, there is a cloud. Maybe after 10 years, there is something else. We need to learn, we need to cope up with that. But there was, and there will always be scope for data related jobs. Okay. Now, let's come to what is Azure. Do you have any question till this point before we start on to Azure?
No, sir.
Now, how many of you use music apps? Many of you must be using music apps or streaming services, right? Like Netflix, Prime, Hotstar, whatnot. Okay. Basically, they all do the same thing, right? Netflix give you movies and web series, right? Hotstar also gives movies and web series, sometimes live shows like cricket. Same with the Prime. Okay. What's the difference between these three? Their service, what do you call it? Their service experience, their cost, and their different providers. Okay. Same way in the market, there are different providers for cloud. You call it Google, Amazon, Salesforce, IBM, Alibaba, Microsoft. These are the few providers which provides the cloud services. Okay. They're like, okay, we have cloud, you can come and use it. It's like that. You subscribe to them and you can use them. It's as simple as that. Okay. Now, Google Cloud is GCP. Amazon is AWS. Salesforce is Salesforce. IBM is IBM Cloud. Alibaba is Alibaba Cloud. And Microsoft's cloud offering is called as Azure. So if I put it into terms like name, this is the cloud service or offering provided by Microsoft. That's the name Azure. Okay. No confusion, nothing. You should be clear what is Azure on. Is something, it's not a tool, it's not a technique, or it's not a skill. It's a service offering provided by Microsoft Azure. That's all. Okay. Now there are yeah. Any question?
No, sir.
Now, various companies choose between the service offerings to use into them, and they have different factors while choosing. Okay. You might be wondering today, let's say I'm working on Azure, I'm learning Azure, and what if I want to shift into Google Cloud or Amazon Cloud or Salesforce, whatever it is, okay? I won't be, it's not difficult to shift from one cloud to another cloud once you have a hands-on experience on one cloud system, because most of the services that they provide are relatable to each other. Like Microsoft Cloud offering for storage, there will be something else into Amazon storage as well. Same will be in Google Cloud as well. The only difference is like how their UI works, how their costing works, how are their interfaces, and like that. Okay. So focus on one cloud, learn that, and you will be good. Okay. Now, in Microsoft's Azure, okay, there is a terminology called pay as you go. Okay. Why I'm stressing on this, or why I'm telling you at the start of this is one of the advantages that we talked into cloud, and Microsoft called it as a pay as you go. Okay, whenever they advertise their cloud to the people, they say that we have a pay as you go service. It means whatever you use for, you need to pay only for that service. Okay, there are some services which are lifetime free, but which are very least used. Okay, now Microsoft Cloud is the second biggest, have the second biggest market present after Amazon. okay, and it is still continuously growing. If I have to provide you one point difference between Amazon and Microsoft Cloud is the UI of the Microsoft Cloud is very simple, straightforward. The costing is very simple. I won't say it is straightforward, but it is simple. It is little bit tricky when it comes to Google Cloud, but yeah, it is simple and you can easily understand it if you go a couple of times. Okay. Now Azure offers you various services. Okay. Now when I services, I'm not categorizing them into these three. Okay. You can have a separate categorization, or when I show you the Azure portal, you can find them categorized into different things. Okay. So various services that provided by Microsoft Azure and are very frequently used by the data analyst or engineer. Okay. First and foremost is storage. Without storage, there would be anything. Storage, compute, the Azure Data Factory. Okay. Mm, yeah, I would stop on these three services. There might be something you have heard like this. Okay. You have heard like this, or people generally say that, have you worked on Database, do you know Azure Database and like that, or they just say simply Database. Okay. If they're saying simply Database, that is correct. If you are saying Azure Database, then it is slightly technically incorrect. Okay. The reason, Azure provides Databricks, but Databricks is not the part of Microsoft Azure. Okay. Databricks is a separate company. It is a separate tool. Microsoft provides Databricks as a first party service. Okay. And that's why people say that it's Microsoft, like Azure Databricks. Have you worked on Azure Databricks or you learned Azure Databricks or not? Okay. When I say first party service, when we go into Azure portal, I show you why I'm saying first party. First party service, it means that you can directly subscribe to Databricks from Microsoft Azure portal. Okay. Second advantage of first party services, if you face any issue into Databricks while working onto that technical issue or any kind of issue, whether it's not working or like that, the first point of contact or the first point of service provider is Microsoft. They have their own expert team in Databricks. You raise a support ticket, the Microsoft first will assist you. You don't need to go to Databricks. Okay. And hence, you can use Databricks with various other cloud services as well, or even individually as well. Okay. Yeah, I just wanted to stress onto that point. Now in storage, there are multiple storage provided. Let me put it this way, ATLS. I will categorize this is my own kind of categorization, or you might find similar into that Azure. When it comes to storage, there are these three kinds of storage I can categorize when it comes to Azure. One is blob storage, ADLS, and DB means database storage. Okay. Now, database storage can be of any service. There are multiple services which provide database. It's Azure SQL Database, Azure SQL Data Warehouse, Azure SQL Analytics, Cosmos DB, are all the services which I will show you in later part of the session onto the portal. Blob storage and ADLS storage. ADLS is basically Azure Data Lake Storage. Okay. Now, before we jump onto the storage and I kind of explain you, traditionally, or few years back, going to few years back, okay, most of the companies were comfortable or using Excel for their reporting. After some time back, we have various reporting tools, Power BI, Tableau, ClickView, and whatnot. They were comfortable using SSIS or copy pasting the data from one thing to another. Okay. But now there are different ETL tools, transformation tools, various reporting tools, and various compute tools as well. The reason for that is evolution of data. When I say evolution of data, it means earlier the data used to come in a structural format. Okay, structural means something which you can put into a structure. Let's, in simple words, a tabular format. If you put that data into an Excel and you can see clearly a different columns and rows of that thing, it is basically a structural format. Okay, and that's how the data used to be. Okay, but since the advancement, hold on a second, someone is supposed to. Since the advancement of various tools and technologies, like you can say internet, mobile, or whatever, okay, the data generation, data collection forms has been changed or keeps on evolving and keeps on changing. After some time, there is called semi-structured data. Then there is something called unstructured data. Okay. Semi-structured data is, it is not straight directly into the structural format, but if you apply some logics and transformation, you can put this into a structural format. Okay, like a CSV or TSV or any kind of file where you have fixed or a specific separator. If you replace that with, if you transform that, basically you can put that into structural format. It's a semi-structured data. Okay, the advantage, you are saying it's just a separator, why do we need a semi-structure then? Okay, the advantage between these two, structured and semi-structured, is the places that we can put a semi-structured data and the size. Okay, size really matters when you keep on working on something for a long time, like 2 months or 3 months. The size keep on increasing. Increasing the size means increasing the compute. Increasing the compute means you are paying more for storage, for compute, for even going through that particular thing. Okay, so you might wonder, I am just receiving 100 MB of file every day. Why do I need to worry about size? Okay, it's not only one file that you're receiving. It's not only one day that you'll keep on receiving. Okay, now unstructured data. We watch YouTube videos, we watch streaming videos, we watch what learning videos. We share images, we share MP3 files, we share JPG files. How do you store that data? If I try to put everything into a SQL table or a table or Excel, will that work? No. This data doesn't have any structure, and that's why it is called unstructured data. And due to these different kind of data formats, we have different kind of storages. They serve the purpose of satisfying the need of different kind of data format. Blob storage, you can store all these three kinds of data. ADLS, you can store all these three kinds of data. Database storage, you need a structural data. If you transfer semi-structured data, you can put this into that. Okay. Now with the slide manipulation, you also can put the semi-structured data into a database as well. Okay. Any questions into the data formats or types of data structures?
No, sir.
Okay. Now, the other part of the services that we frequently use is compute. Okay. Now, this compute can be integrated with some other service like storage or data factory, or it can be a separate. Okay. I'll give you the separate example here is like virtual machines. Okay. Virtual machines are nothing but a CPU which is placed at some other location, and you are accessing that CPU from your laptop or desktop. Okay, you have the IP address, or we call it a VM address or server address, whatever. Okay, you install that software or it is already pre-installed on your machine. Okay, and we put the IP address, server details, username, password, and we access the virtual machine. Okay, virtual machines, as I mentioned, nothing but the CPU. Okay, why do we need the virtual machines? Okay, we already have our own laptop or desktop where we can do everything. Why do we need virtual machine? Okay, you are working for a company A, okay, and that is working for a company B. Okay, company B doesn't want to give the data to company A, but they still want company A to work on their data. Now you are saying it's like, okay, I need to buy iPhone, but I won't use iOS. Okay, so for that, it's a virtual machines. What we do is I'm working at a company A. I go to company A's office. I log in into company A's laptop or desktop. Then I put the IP address or VM address or server address of a company B, okay, which let me access the company B's machines. That company B's machines will only have access to company B's data. I will do all my job on company B's machine. The transformation, the reading, writing, whatever will happen into company B's network and company B's machine. And that's why from company A, I'm accessing company B, I'm doing that job. Okay. There are limitations also people put that they generally they put this. You can't copy data from virtual machine to local machine. And sometimes you can do also. It depends on how security is implemented in that company. Okay. But this is basically the use of virtual machine. One use. There is second use also. Company A might also provide you virtual machines. Okay. The reason is it is a standard practice, or it was a standard practice that earlier organizations used to work on a desktops. Now everyone got a laptop, but still there are some people who work or companies work on desktop or in the laptop as well. That they used to provide a basic configuration: 2 GB of RAM, 500 GB of hard disk, a basic processor which will keep your computer running, like Outlook, Teams, normal softwares, like that. Okay. And then they used to provide a virtual machine within a team, a one virtual machine within a team, okay, which has a higher configuration, which only needs for that particular job. Okay. So all 5 people working into that project will access that virtual machine, okay, within the same company, and will work on 7 people on one single machine at the same point of time. It is to save the cost, because when you are not working, you are not using that machine, you can just shut it down. Okay. Any questions onto the virtual machine and its usage?
No, sir.
No, sir.
No, sir.
Now data factory, okay, or Azure data factory. If you have worked on or heard of SSIS, Azure Data Factory is the cloud offering of the SSIS. It is not same as SSIS. The UI is totally different. The functions are totally different. But to relate it to that particular thing, I am giving an example that it is the cloud offering provided by Microsoft for the SSIS. Okay. Now, those people who don't SSIS, it's fine. Azure Data Factory is an ETL tool. Now, let me stand corrected here. More specifically, it is ALT tool. Okay, it's not a ETL tool, to be precise. I'll tell you the reason. The reason I put here ETL tool is, if you are not familiar of SSIS or you are new to this whole part, that's why I put the ETL tool, which is everywhere commonly used. ETL is nothing but extract, transform, and load. Okay. Why do we need such a tool and what's the usage? Okay. As I mentioned, there are various sources of data where data is generated. Okay. Let's take an example of a say company, a retail company. Let's go with the Star Bazaar. You must have heard Star Bazaar, Tata Star Bazaar, or whatever offering you have nearby places. Okay. Customer data is generated as a POS stations. Wherever have the Star Bazaar shopping center, we go there, we shop it. The customer data is generated there. Okay. The manufacturing data will be generated at some place where manufacturers are located or their warehouse are located. The internal data will be generated at their internal system. Now, when you involve with multiple people, multiple vendors, multiple location, not everybody stores data same way. Okay. There might be people who are storing data in Excel. There might be people who are storing data into CSV. There might be people who are storing data into database storages. Now, there might be people storing data into various database storages. One can be using Oracle, one can be using Microsoft, one can be using IBM, one can be still using Informatica or keep continuing Informatica, right? So various people tend to use various system, tend to use various format within the same system. Various vendors tend to use different system, okay? So even though within one single company or a Star Bazaar, there can be these different ways of data is being gathered. Okay. Now, if I want to analyze the data, okay, my manager asked me, let's say, tell me what is the purchase pattern against the locations. Okay. Now I need to gather the POS data. I need to gather the online data. I need to gather the inventory data, all this kind of data. And if it is not a centrally located or some place where I can, look up all this data, compare all this data at one point of time at a single location, I need the ETL tools. Okay. The purpose of ETL tool is they connect to these various different systems. Okay. There are connectors provided within those systems. Okay. You use those connectors, you connect to those systems. Okay. You connect to the data and you bring that data to your own system. Okay, a centralized system that you created for everything to gather there. And that is basically Azure Data Factory or ETL tools are. Okay. Now, connecting to system and getting the data is basically extract. We're extracting something from the other system. Okay. Transform. Okay. Let's say I'm reading a CSV file or a file which is comma separated, tab separated, or JSON file. Okay. And I'm trying to put that into central system, which is my database. Now I need to put it into a table. Okay. I need to transform that CSV first of all into structural format. I will, let's say, remove some data, filter some data from that. I will clean up that data if there are some inconsistencies in that. I might transform. Basic example of transformation. Let's say there are two different fields for first name and last name. Why I don't need a two different field. I just combine first name and last name and bring and put it into one single field. Okay, that is transformation. I might apply some complex transformation as well. Okay. So that is transformation. And after doing that, putting that data into my centralized location is loading. I'm just loading that data now. Okay. This is extract, transform, and load. All right. Now, why did I mention the ELT tool for Azure Data Factory? Why I was stressing on that is Azure Data Factory is a cloud offering by Microsoft and is basically it does all the job that on-premise system does. Okay. But it's meant for the large workload. Since our data volume is large these days, it is meant for large workloads. Okay. Extraction is same. I connect to different sources from data factory and I pull the data. It is fine. Now, instead of transforming, what I do as a next step is I load that data into my centralized location. I don't transform it. I just get it as it is. Okay. And after putting that into centralized location, I transform that data. And why do I do that? Why do I do the process in reverse way? Why everything is first ETL, now ELT? All the extraction tools, okay, have a compute of their own for the transformation, for connecting, for this stuff, okay? But it is limited. You can scale that up, but still it is limited, okay? Second thing is the transformation that you apply, the number of transformations or operation that you perform is limited or can be limited, okay? It might be possible that all the things that you want to do is not visible there. Okay. Or you might not be able to connect to different data sets there. And the third part is the time. Okay. When I'm extracting something, it will take lesser time when I'm trying to transform that something and then extract. Okay. And the fourth and foremost thing nowadays is consistency. No, I won't say consistency, integrity of the data. Okay. Or how do I put it in simple words? Okay. As I mentioned you one thing, right? First name and last name portion. Okay. Or I also mentioned that I removed some data by transforming while getting a data into my system. Okay. Let's say after 5 months, I happen to have a requirement where I need that removed data, which I already removed from by bringing that, or I need those first name and last name columns separately in that specific requirement. So what will happen in the second case is I need to again from my centralized database, I need to use that particular object, separate the two columns and use it somewhere. Okay. And if I remove data, I don't have the data. I need to go back to the source system, check whether that it is available there. I need to bring back again the entire data and use it. Okay. But if I don't filter on anything, if I don't remove any column, and I bring it as it is, I load it into my central system, then I can use it anywhere, whenever I want to, and however I want to. I don't have to go back and look into the source. So generally, a thumb rule for ETL or ELT work is you should always try to make sure that whatever is there in the source system always matches with your destination system, whatever you're putting into, so that your system is flexible in a way that in the future, if you need the any column out of the data, you have that. You need all the rows, you have that. Okay. And that is why data factory is a more of a ELT tool than a ETL tool. Okay.